Hello again. This is the midterm key for Math 1635. Because the final exam will be comprehensive and you might get asked questions similar to some of these. Number one, ask you, a survey found that the American family generates an average of 17.2 pounds of glass garbage each year with a standard deviation of 2.5. Find the probability that the mean of a sample of 55 families will be between 17 and 18 pounds. Well, you know that this distribution is going to be normal because the sample was more than 30. And you then also know that the mean is going to be the same, 2.5, but the standard deviation is going to be the 2.5 divided by the square root of 55. So this is what you use for the normal distribution. And so the probability that it was less than 17 was 0.27649, and the probability that it was less than 18 was 0.99118. You take the difference between the two to be between, and you get the probability should have been 0.71469. Here in problem 2, I gave you a bunch of data and probabilities associated with each of those, and you wanted to find the mean of this discrete probability distribution and the standard deviation of this discrete probability distribution. So here's the formula for the mean, here's the formula for the standard deviation, and you do the calculation with Excel. You get that the mean was 2.525, and the standard deviation was 1.422454. And here are the calculations using Excel. Okay, number 3, the ABC company makes toy robots. The probability of a defective robot is 0.04. 0.04. And if you buy 35 of these robots, what's the probability that exactly 4 are defective? This is a binomial distribution. N is 35. You wanted to have exactly 4, and the probability of a success was 0.04, and it's not cumulative. So you get this answer for A, 0.0378, and you could have more numbers if you want. Now, the second question asks, what's the probability that more than 30 are not defective? So that would be 31, 32, 33, 34, or 35 are defective, but that corresponds, are not defective. That corresponds to 0, 1, 2, 3, or 4 being defective. So you add these up using the same Excel function and get 0.987787, and that was the answer to part B. Number 4, we were looking at a Poisson job distribution, and the arrival rate was an average of 2 per minute, and we were conveniently talking about a 1-minute interval, and so that made the calculation pretty easily. You use the Poisson probability distribution shown here. T is 1 and lambda is 2, and you could have done this in Excel, which I would recommend. So if it was 0, you get 0.135335. Exactly 2 was this number here, 0.270671. At most 3, you could use the cumulative probability distribution shown over here, and you get 0.857 and 1, 2, 3. And what's the maximum jobs that should arrive 1 minute with 90% certainty? Well, you actually were at 94% probability if you were at 4 and you were at 3, so I counted 3 or 4 to be correct on that problem. Number 5, if you had 12 males and 8 females in a jury pool and you were picking 8 of them randomly to sit on a jury, what's the probability of selecting 5 males and 3 females? Well, the males are 12 choose 5, and the females are 8 choose 3. You multiply those together as those are separate steps, and the 20 choose 8 is this, so that's your denominator. So it's the product of these two numbers divided by that number, and you get 0.352 0.084 as your final answer. Number 6, a company was using statistical controlled. They have a mean of 12 and a standard deviation of 1.8, but they sampled 5. So you have a central limit theorem. The mean is 12, but this standard deviation is going to be 1.8 divided by the square root of 5, and that will give you this number. So the upper controlled limit, again, I told you they were doing 3 sigma. So the upper controlled limit is 12 plus 3 times that number of sigma, which gives you this number, 14.4 and change. And the lower controlled number is going to be 12 minus 3 times that number, and that's going to give you 9.585047. Okay, this is the Titanic problem. The first question was, if a passenger is randomly selected, what's the probability this person was in first class? Well, a person is randomly selected. You had 324 divided by 1317, and that gave you this number 0.24, and we got that just from the conditional probabilities up here. If a passenger is randomly selected, what's the probability that they did not survive? Well, they did not survive. It would be 817 divided by the total, which was 1317. That gives you this 0.620349. The third question was, what's the probability that the passenger was in first class and did not survive? Well, first class and did not survive, this is 123 over 324, and that's the conditional probability. That gives you 0.37963. And problem number 4 was, what's the probability the passenger was in third class and did not survive? Well, third class is here, and so it was 528 over 709, which is 74.4%. And notice that this actually proves that there was a dependency between class, and I refer to that in the next problem. Number 8 said, using the same data, what's the probability of surviving given that you were a crew member? Well, you see these numbers that were given was for passenger and crew was 710 survived out of 2204, passenger and crew combined. So if you subtracted the passengers from the total, you got 887, and if you subtracted the 500 that survived here from that, you get 210. So this answer is going to be 210 divided by 887, and so that gives you this 0.236753. That's your answer. And again, to talk about the survival rates being independent or dependent, they certainly were dependent, and this is one example that you could have cited. Number 9 was a Bayes formula thing. So if you were in company A, 80%, and the failure rate was 0.04. If you were in company B, they had 15%, and the failure rate was 0.06. And company C was 5% of the market, and the failure rate was 0.09. So you get these 3 numbers. So we take the first one, which was the question that was being asked, 0.032, and divide it by the sum of these 3, and you get that that is going to be 0.703297. Problem 10, you were to do least squares regression, and so what you did is you take T and L. The explanatory variable was T, and the lifetime was L, was the response variable, and the correlation is negative 0.99199, and the critical number is from our table for this number of data points was 0.666. Since the absolute value of this is bigger, that is good enough to use, and you should have explained that by comparing the absolute value of this with that number. I talked about what the explanatory variable and response variable was. If you do the least squares regression, you will get that the slope is minus 5.31333, and the intercept is 0.453, 0.55 or 5 and 3/5 and then a 6. And if you plugged 27 degrees into that, you would get 310.09 as your answer. So these were the correct answers. Number 11 was a straight up normal distribution problem. Here was the mean and here was the standard deviation, and you used your table to figure out what's the probability that you're greater than 500, and the answer would be 0.59525. Number 12, you were supposed to say what score on the GMAT is required to score in the top 5%. So we mark off the top 5% here, and we figure out what X has to be, and we find that X is, and I would count either 711 or 712 to be correct on that problem. Here, you could have answered this differently, but you could compare and probably should compare the z-score. So the z-score on the GMAT was 0.116071 above the mean, and for the GRE it was 1.56 and more standard deviations above the mean. So the GRE was the better score. You should have explained it that way. Here you were talking about a bag containing 12 balls, 5 green and 7 red, and you draw 2 balls without replacement. What's the probability of getting one of each color? Well, you see, you could have gotten the green one first, or the red one first, or the red one first, or the green one first. And so you would say that the probability would be either 5 out of 12 times 7 out of 11, or it would be 5 out of 11 and 7 out of 12, but there's 2 times those probabilities. So when you do the full calculation, because you could have gotten one or the other, it is 0.530303. And last but not least, I gave you some data. You had to sort the data and look at. The mean age was rounded to the nearest decimal point, was 35.5. The median age was 36. There were 3 modes, 37, 53, and 66. The standard deviation rounded to this one decimal point was 18.8. The first quartile was 22. The maximum was 72. The minimum was 1. The third quartile was at 50. If they met again in 5 years, it would just add 5, so it would be 40.5, and the standard deviation would not change. It would still be 18.8 because that measures dispersion. And so there are your solutions, and you can compare your work to this, and this will help you prepare better for the final exam in the course. Please take care.